Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Converting an amine, NH2, directly to a nitro group, NO2, on a benzene ring requires an oxidizing agent capable of oxidizing the amino group all the way to a nitro group. Moving on to the next step. Identify the transformation. Aniline, PHNH2, must be converted to nitrobenzene, PHNO2. This is a net oxidation of the nitrogen from -2 in NH2 to +3 in number 2, a significant oxidation. Moving on to the next step. Evaluate the reagents. CF3CO3H, trifluoroperoacetic acid, is a powerful peracid and strong oxidizing agent. It is well known to oxidize primary aromatic amines, ARNH2, directly to nitro compounds, ARNO2, via sequential oxidation, ARNH to ARNHOH ARNO2. This is a known and reliable synthetic method. H2SO4 is an acid, not an oxidant capable of oxidizing NH2 to number 2. It would protonate the amine but not oxidize it. LAH, lithium aluminum hydride, is a strong reducing agent. It would not oxidize NH2 to number 2. NaBH4 is also a reducing agent. It cannot perform this oxidation. And for the final step, CF3CO3H, trifluoroperoacetic acid, is the correct oxidant for converting ARNH to ARNO2. It is a much stronger peracid than MCPBA or peracetic acid and can achieve full oxidation to the nitro group. Why other options fail? H2SO4 only acts as an acid dehydrating agent. LAH and NaBH4 are reductants and would reduce rather than oxidize nitrogen. Therefore, the correct answer is A. Therefore, the correct answer is option A.